This is an ultraviolet image of the planet Saturn. Saturn looks a little different in the ultraviolet. You can still see the edges of the rings here, but the reason we use the ultraviolet with the Hubble Space Telescope is because of what you see in the poles here. Those are the aurorae of Saturn. They glow really beautifully in the ultraviolet. So the Hubble Space Telescope is one of the key tools that we have had to study these beautiful aurorae of Saturn. This is a sequence of ultraviolet images with the Hubble Space Telescope, and what you can see is how dynamic they are. They don't just sit there glowing. The glowing part is changing all the time. And it's changing because our sun is changing, and our sun is spewing out particles all the time, and when these particles hit this planet, they get sucked into the magnetic field, and then they get deposited at higher altitudes. So what you're seeing here is really a combination of Saturn changing, but also our sun. What's particularly special about this Hubble image is it was taken at a time close to what we call the ring plane crossing. So the rings are almost in a straight line relative to us. They almost disappear. Saturn takes 30 years to make a trip around the sun. So the Saturn year is 30 Earth years long. We only get this particular orientation twice in that 30-year orbit. So every 15 years, we have an opportunity to see this sideways view of Saturn. Most of the time, Saturn is tilted one way or the other relative to the sun and to us. And what's great about that is that it allows us to see both the northern and the southern pole together at the same time. By using the Hubble ultraviolet observations, we can see the aurorae, that's the first thing, and we can actually see variations in the aurorae around what we call the auroral oval. And that allows us to track out the strength of the magnetic field depending on how bright these aurorae are. One of the things you can tell from an image like this from Hubble is that the aurorae in the north and south are pretty comparable in brightness. And that means that the magnetic field strength here is pretty similar in these two poles.